Welcome back to a new machine learning tutorial. In this video, we are going to talk about the decision tree regression. We are going to talk about the logic behind the algorithm, how we can code it in Python. We are going to talk about its parameters, and we are going to talk about how we can do hyperparameter tuning using Python scikit-learn. Let's start coding. I'm in Visual Studio Code right now. You can use any code editor that you want. It's completely up to you. And I'm going to be closing the welcome page right now. And I will say decision tree regression .ipynb. And now I'm going to say decision regression in here, and I'm going to be selecting my kernel as 3.11.4. Great. So let's talk about it. Decision tree regression is a type of machine learning model used for predicting continuous values. So we can use it for our regression problems. It splits the data into subsets based on feature values, aiming to minimize the variance of the target variable within each subset. The model builds a tree-like structure, and I'm going to be typing the important keywords where each internal node represents a feature test, each branch represents the outcome of the test, and each leaf node represents a predicted value. So let's code it. So we are going to start by creating a base model in this video. Then we are going to talk about the parameters of the decision tree regression and how we can do hyperparameter tuning, which means getting the best performance from the model with optimizing the parameters. And so we can start to our coding part right now. So what I'm going to do is I'm going to do my imports for the data creation. Firstly, I will say from scikit-learn datasets import make regression, and I will say from scikit-learn.tree I'm going to import decision tree regression like this. Now I'm going to say model selection import train test split, which is super important for evaluating our models, and I'm going to be importing the mean squared error also in here. So this is going to be our error metric in here. So simply mean squared error does, like, let's write it, its formula. So it gets the sum of the all y true minus y predicted values squares, and then it divides it by n. So n is the number of samples. This is going to be the true y values in its train test split, and this is going to be the predicted values from the model. Okay, we have our libraries right now. It's time for data creation. So I will say x and y, then I will say make regression. Number of samples, I'm going to say 1000, and number of features, it's going to be 1. Then I'm going to say noise is going to be 0.1. So when I call x, we are going to have this array, and when I call y, we are going to have this array. Now we can make train test split. So in train test, we are going to be splitting this data into training and testing sets for training our models with the training set and testing our model with the testing set. So we are going to train our models with X train and Y train, and we are going to test them with Y test and X test. So I will say X test, Y test, train test split, X, Y. Let's set the test size as 0.2, which means that 20% of the data is going to be in the testing set and 80% is going to be in the training set. So we have 1000 samples, and 800 is going to be in the X train and Y train, and 200 is going to be in the X test and Y test. So we can also check that X train and length of the Y test. So we can see 800 to 200. And we are going to be training our model with X train and Y train, which are going to be our label, Y train side. And we are going to make predictions using X test, and we are going to compare their performances with Y test. Okay, so now we are going to train our decision tree regression model, but we are not going to do any kind of parameter operation in here. So I will say model is going to be decision tree regression, and then I will say model.fit. And I'm going to say X train with Y train. So we trained our model. Now I'm going to make predictions. Let me show you what it returns. I will pass xtest in the predict method, and here is my predictions using my xtest. So let me quickly show you what xtest looks like. And we have values like this, and we predict values like this, the values returning from the model.predict. And now it's time to compare it with the y true values. So y prediction is going to be this, and I will say mean squared error is going to be mean squared error y test with y predictions. So these are our true values and these are our predicted values. So let's get our mean squared error. It's 0.82. So the decision of this value is good or bad is completely up to your case. You can check your data's values, like you can say from numpy, I will say numpy.mean, and I will pass the y in here. So the mean is, and you can get standard deviation on the y and compare the values with this. So it's case specific and not the topic of this video, so I'm not going to be talking about it. And now what I'm going to do is I'm going to talk about the parameters this model has and how we can do hyperparameter tuning. So firstly, let's start by importing the grid search from scikit-learn model selection. And we are going to do the hyperparameter tuning with grid search. Now we are going to define the hyperparameter grid, which is going to be our list for possible parameters we can pass into the model. So I'm going to be starting with the max depth. So max depth is basically the maximum depth of the tree. So I'm going to give it a list like none, and I'm going to say 5, 10, 15, and it's enough. You can extend these values for better performance. Like you can add 20, you can add 30, you can add 1. You can make additions to the both sides, like you can say 2, 3, 4, 5 at the start and say 15, 16, 17. Values up to you and up to your case. But I want to tell you that more values you enter in here, more parameters are going to be trained and tested out, so it's going to be meaning more computational resource. So I will say minimum samples split for the next parameter we have at the decision to regression side, and it is minimum number of samples required to split an internal node. So I will say 2, 5 and 10. And again you can extend these values. I will say minimum samples leaf, and it is minimum number of samples required to be at a leaf node. So I will say 1, 2 and 5. Next I will say maximum features, and we can say none, auto, square root, and this value. So this maximum feature means number of features to consider when looking for the best split. Okay, let's set it out, and now we are going to perform the grid search. So let's firstly set it. We will say grid search, and we will say grid search cross validation. We are going to say estimator is going to be the decision tree regressor, and the parameters we are going to give is going to be the parameter grid. And let's set the cross validation as 5, and let's set the scoring as negative mean squared error. By the way, we want mean squared error to be lower because we want the difference between the actual value and the predicted one to be close. So the lower mean squared error, the better model is. We can think it like in simple. And cross validation 5 means we are going to have 5 folds in our data set, and I think we are good to go. By the way, I have tutorials about all of these topics like hyperparameter tuning, cross validation, negative mean squared error. You can check my channel's machine learning tutorials playlist for tutorials on that topics. I'm trying to make this video short and useful, but you can check the tutorials. And I will say grid search. Now we are going to fit the grid search using the X terrain with the Y terrain, and here we can see our model, and we can say best parameters, and we can use grid search best parameters method for this. And now I will be printing the best parameters, and let's see what are they. So at the max depth side we have the none, maximum features none, minimum samples leave 1, and minimum sample split we have 2. So how we can use this best estimator. Like this is the best estimator in our parameter range. And how we can use that is you can directly use best parameter, not best parameters, grid search. That the thing we set the grid search on, this one, and we can use directly the predict method on that. And also we can use best estimator, then we can use predict or feature importances like this. It's completely up to us. By the way, we have one feature, so it's one, but you can use predict method by passing an x value in two-dimensional format. Let's use an application like, let's pass the third value, and I'm going to be getting the 250 when I pass my value in a two-dimensional format like this. Great. This is how we can do hyperparameter tuning, and again you can extend this list in the way that you want. And also let's evaluate the model we tuned. I will say y prediction tuned, and it's going to be best model. Actually, let's say grid search dot best estimator dot predict, and I will give the x test like this. And now I will say mean squared error tuned. It's going to be mean squared error between the y test and y predictions tuned. Let's print it out and see our value. So it's 0.82. So for improving the performance, you can extend this list. Like you can check, like let's do an example. We see that at the minimum sample split side, we have the 2 is selected. So we are coming to here, minimum sample split. We can extend this list in this order, like maybe 1, 3, 4 is going to perform better. We can just add that values into this list. And this is how we can do hyperparameter tuning on a decision tree regressor. So let's summarize what we did in this video. We start by talking about the decision tree regressor, logic behind that, and then we imported make regression for data creation. We imported decision tree regressor since it's the topic of this video. We imported train test split from the scikit-learn.model selection. We imported mean squared error from scikit-learn.matrix, and I talked about mean squared error quickly. Then we create our x and y in here. I create a really simple data set like 1, but decision tree is a great algorithm for dealing with a lot of features. Like if you have 10 to 15 columns in your data set, it's going to be performing really good based on the structure of your data, but I'm trying to say it's a powerful algorithm. And then we do train test split, and we initialize our base model, we trained it and checked our mean squared error. And I showed you how this can be value good or bad depending on your case, and how you can check your values. Descriptive statistics like standard deviation, mean, variance, completely up to you and your case. And then we imported grid search cross-validation for hyperparameter tuning, and we defined our parameter grid, and in here max depth is the maximum depth of the tree one more time. Minimum sample split is the minimum number of samples required to split an internal node. Minimum samples leaf is the minimum number of samples required to be at a leaf node. And maximum features is the number of features to consider when looking for the best split. We have one feature in this dataset, so the decision tree regressor maybe not the best pick, but I want to show you this algorithm with a really simple dataset. But you can extend this list if you have a really big dataset, and the more values you try, you are going to have both things. 1, more computational resource. 2, more chance to get a better model. And now, after that, what we do is we set the grid search with the parameters. We set the cross-validation as 5 for having 5 votes, and the scoring is negative mean squared error. Then we use grid search.fit, and then we get our best parameters. Here is our best parameters. Then we make a prediction by passing a two-dimensional array in the predict method. Then we evaluated our tuned model, and we got the mean squared error. Thanks for watching this tutorial on decision tree regression. I have a machine learning tutorials playlist where I have more than 40 videos just like this one. You can reach to that playlist from the cards of this video or from the description. I'm sharing new data science videos every week on my channel. You can subscribe for more videos like this. Have a great day.